Welcome back to Zuluwa Consultants. In this video, we want to answer this question under the topic acid, bases, and salt. The question that we have reads, at 25 degrees Celsius, the concentration of H positive is 4.6 times 10 to the power negative 8 m. So they are asking us to find the concentration of OH negative, then thereafter to determine if this solution is acidic, basic, or neutral. The first thing we need to know is what is the value of Kw at 25 degrees Celsius. Now, the equation for Kw is Kw, which is the equilibrium constant, is equal to the concentration of the proton multiplied by the concentration of OH negative. Now, at 25 degrees Celsius, this is equal to 1.0 times 10 to the power negative 14. So this value is only when the reaction is taking place at 25 degrees Celsius. So we have different values of Kw at different temperatures. So you need to pay attention to the temperature that is on the question. Depending on the temperature, you'll be given the value of Kw. And in some question papers, they can give you the table that shows different values of Kw at different temperatures. For this video, we have exposed this table as a way for you to know that Kw differs at different temperatures. Now, if you know that Kw is equal to 1.0 times 10 to the power negative 4, we have been given the concentration of the proton, which is S positive. So we can say 1.0 times 10 to the power negative 14 is equal to the concentration of H positive is 4.6 times 10 to the power negative 8 multiplied by the concentration of OH negative. So we want now to calculate the concentration of OH negative. We can make it the subject of the formula by dividing both sides with 4.6 times 10 to the power negative 8, 4.6 times 10 to the power negative 8. So these two will simplify. We are now going to have the concentration of OH negative is equal to 1.0 times 10 to the power negative 14 divided by 4.6 times 10 to the power negative 8. So let's see on the calculator what we are going to get when we divide 1.0 times 10 to the power negative 14 divided by 4.6 times 10 to the power negative 8. So the answer for the concentration of OH negative we are getting is 2.174 times 10 to the power negative 7 m. We can round this off as the concentration of OH negative is equal to 2.2 times 10 to the power negative 7 m. So this is the concentration of OH negative. Now the question continues and it is demanding us to identify if this solution is acidic, basic, or neutral. There are these 3 points that help us to identify if this solution is acidic, basic, or neutral. The first point is, if the concentration of H positive is equal to the concentration of OH negative, then the solution is neutral. So what does this mean? If this value is equal to the concentration of H positive that we have been given in the question, we would have said this solution is neutral. In this case, these two answers are not the same, so we can say this solution is not neutral. The second point says if the concentration of H positive is greater than the concentration of OH negative, then the solution is acidic. So we need to compare these two values. Is this value less than this? You'll notice that this is not greater than this value. Hence, this solution is not acidic. The third point is telling us that if the concentration of H positive is less than the concentration of OH negative, then the solution is basic. When you look at the concentration of OH negative is greater than the concentration of H positive. So what does this tell us? This tells us that this solution is basic. Why are we saying so? Because this value is greater than this value. Hopefully this video has been very helpful to you. Do not forget to subscribe to our YouTube channel and follow us on our Facebook page if you have not done so. Until next time, it is bye-bye.